Okay, welcome everyone. My name is Heike Ritter and I will be your host for this webinar. Thanks for joining and thanks for being part of our community. A few reminders before we get started. All these webinars will be recorded and shared publicly afterwards on our community at aka.ms/security-webinars. During the webinar, please feel free to ask questions at any time by typing them in the live event Q&A window by clicking on Ask a Question. Questions you post might be made publicly visible, and if you prefer, you can post your question anonymously by checking the box right below where you enter it. We often can get many questions here, and we're doing our best to respond to all of them in real time. If the answer was not provided, if you have additional questions afterwards, or if you're actually listening to this after the fact as a recording, please don't hesitate to ask them on the Microsoft 365 Defender forum at aka.ms/M365DTC. Please also join that community, so that's the best way for you to ensure you don't miss any future webinars or major announcements. And in our community, you can speak directly to the engineering teams that are actually building our product, so please join us. At the end, of course, we would love to hear your feedback on how we can improve these webinars. Please do so at aka.ms/security-webinar-feedback. This is important so we can deliver the content you need. And today we have another epic episode of l33tSpeak, Advanced Hunting in Microsoft 365 Defender, and handing over to you first, Tali.
Thank you, Heike. Hi, everyone. I am thrilled to open today's episode with new enhancements to advanced hunting capabilities in Microsoft 365 Defender. We are sharing with you today a new hunting page that includes an improved layout and new features in it. Then we will discuss how to import an external data source into your query and query partitioning. For the second part, I recommend that you will follow the link we are pasting now in the chat to our Git so you can use the queries together with us. All the queries we will run in the webcast will be available to you. So let's start. Welcome to the new hunting experience. This is the new hunting page. We heard you and built an improved page to help you hunt more smoothly. You can now work on multiple tabs. The multiple tabs are finally here. You can open new tabs to work on multiple queries in parallel. Every time you open a saved query or a detection rule, the query will open in a new tab. Let's find an example. Yes, right here. And this is a major thing. We know we waited for it, so it's finally here. To avoid confusion between time filters you write inside queries and the GUI time filters, we added an improvement, I can say, that we know to identify when you have time filters in your query. So the GUI here is showing you that the lookback time of the query will be according to what you wrote in the query. If you would like to use the GUI time filters, you can do that, and you can choose one of the options. So it's a new improvement to avoid confusion, and we know to identify automatically. After running your queries, you can now see the query execution time and its resource usage, which can be low, medium, or high. High indicates that the query took high number of resources and should be improved to be more efficient. Many times we discussed in the past the query efficiency and how important it is to write efficient queries. In this webcast series, in other documentation we shared, we warmly recommend and even guide you every time you see the query took medium or high resource to go to our documentation and follow the best practices, to use the recommendations and make sure you write the most efficient queries you can. Let's look at the results set. You can now view the results in a much more convenient way. Say goodbye to regular pagination. We now support smart scrolling. When you scroll down, the list expands automatically, so you can focus on the results. You can actually leverage the entire screen to look at the result set. If you would like to copy value, you should just hover it and mark the value you would like to copy. You can open the record side pane from records to focus on a specific record in another way. And if you would like to add filters to the query directly from the results, you can do that directly from here using these 3 dots. If, for example, we would like to add to this query the device ID filter that does not equal this device ID, we can just click on that and it will be added to the query. We also support more advanced filters based on the column type, which is found here. Let's go back to our schema. As you can see here at the left, we reorganized the tree. Now you have tabs for each category: schema, functions, queries, and detection rule. Inside queries, you can find all the community queries in its own section. We think here all the content we upload to our community in the GitHub. And if you would like to edit a saved query, you have these 3 dots that provide you the option to open it in the editor, which is equivalent to double click, rename it, or delete the query. The next thing I would like to show you is that the Getting Started section has a new home. It's just here next to the results. You can switch between the results and Getting Started. It can be very helpful and valuable for new analysts or analysts that are new to KQL. It can help you learn some basic operators, more advanced operators, and when you click on a specific operator, a new tab will get opened with a sample query that show you how you can use this specific operator. So you can find it here under the query editor next to the results. And the final feature we announced today is linked to incidents. Let me just run this query. We now added an option to link events from hunting directly to incidents. This capability can help you quickly add additional evidence for an ongoing investigation based on what you find in advanced hunting. After you run an advanced hunting query, you can select which events are related to the investigation you're working on. The events you select can now be added as an alert to the incident of your choice. So if, for example, I looked for email events which were recognized as any threat type, is not empty threat types, and were delivered to the inbox, and I would like to select some specific events and join them to an incident as an evidence to my investigation. You can see right here that the delivery action is delivered and the threat type is not empty. In this case, it is spam. And pay attention to the recipient. I will choose 4 events to attach to incident, and all of them has the same recipient. I can choose the events I would like to link and click on link to incident. By the way, please notice that also take actions is available from here. All the actions you can take from the results are just here at the top of the results table. When I click on link to incident, first I can choose if I would like to link the events I found to a new incident, which will create a new incident only with this type of evidence, or to link to an existing one. I can search for an incident by its name or ID. And then we need to provide all the details, the email activities, the alert title, the severity of the alert, the MITRE attack category, description, similar to what we need to provide for custom detections, because eventually we create alerts from advanced hunting. We need to choose the impacted entity, which is very important because based on that, we calculate or actually create alerts from the events. If I will choose here the recipient email address, we just saw that the 4 events I selected have the same recipient email address, which means all of them will be part of the same alert. So from 4 events I chose in advanced hunting, we will create a single alert based on the recipient email address as an aggregator, and this single alert will be added to the incident that they chose, in this case to a new incident that is created. And then we can review it and submit. I already did it in advance, so I would like to go now to the incidents page and look for such incidents. This is a new way to create alerts, and therefore we added for it a new service source. Under Microsoft 365 Defender, you will have the option or the filter manual. If you would like to filter for incidents that have such alerts, you can just do that. And you have the incident over here. And this is the incident I created in advance with a single alert. And we can see here that I want to show you the service source and detection source, that it was created in 365 Defender manually by an analyst. And if we'll go to the alert page, we will find all the events we linked. It is a similar view to the custom detection alert page. We have both timeline view and query results, exactly like in advanced hunting. And again, here we see that it was manually added to the incident. And I will go back to the page now. So yes, this is the new hunting page, and I really hope that you are excited about it and asking yourself when you will have it. So these days we are gradually opening it for all of you. Some of you are already using it, and some of you will use it very, very soon. If you don't see it today, it will get opened for you in the coming weeks. As you can see, we have here this toggle. When you will get the new page, by default, this is going to be your hunting experience, but you still have this toggle in case you find yourself need to go back to the old page and execute or run stuff over there. You can do that by switching the toggle. But please, 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 before doing so, use the give feedback and tell us why you need to go back to the old page. It's super important for us. We want to make sure you can execute and work completely here without using the old page anymore. And of course, as always, please provide feedback on everything you think, on anything you want or think, good things, bad things, it's up to you. And we really, really hope you will enjoy it. So again, it's supposed to be rolled out for you in the coming weeks, and share with us any feedback you have on that. And with that, Michael, I will hand it over to you.
Awesome, thank you, Tali. Those are we got some really great features coming out. I mean, those are some of the ones that I know customers have been asking about for a while. So these should be pretty exciting to see these in production. So today we're going to cover two somewhat advanced topics from an advanced hunting perspective. The first one is external data. Now, external data is a really handy operator that can enable you to bring in external information, something from a web accessible location. So essentially what you're going to do with external data is you're going to provide a URL that has either raw, CSV, XML, or one of a number of different formats of text that you want to bring in and probably join on or pivot on inside your query. So I'll break down real quick how the external data operator is structured. The first thing is going to be to call external data itself. The second thing is we have to tell it what the format looks like. So we have to say, in this case, I'm telling KQL that we're going to have a single column that comes back, and it's going to be type string. And we want this column to be called URL domain. Now, if we take a look here, this is essentially what I'm bringing in. This is from a GitHub source about COVID-19 observable, different domain names that we know to be used with phishing attacks associated with COVID-19 related themes. The third thing we have here is you're going to specify one or more URL sources. So in this case, this URL over here is going to be what we're going to be bringing in, and then we're going to tell it what format to bring it in. So this first one is just carriage return separated. So we're going to use format equals txt, which is a text file essentially. So let's go ahead and run this real quick. And what you're going to see is it's going to bring it all in as a table with a single column that matches what you specified up here. So URL domain is string. Let's go ahead and take a look at a different, let's look at an example of actually using this here. So let's say we take this previous example, this is the exact same request, and we wanted to look inside the email URLs to see if any of these URL domains match any of these. This is an example where you can pull the data in and do a write semi-join on the email URL info. So as a reminder, email URL info is essentially any URL that we saw inside of an email processed by Defender for Office. In this case, we can say there was no emails in the last 7 days that had a URL that matched any of those patterns. Let's get a little more advanced. Let's talk about importing a CSV file. So our second file we have here is this one. This is from Black Lotus Labs, and it's got IOC file name type first seen on virus total. This could be pretty handy as a public threat intelligence source. So just like before, we're going to say external data, but this time we're going to go ahead and pass in all the different columns that are going to match. So the IOC is a string, file name is a string, type is a string, and first seen on VT is a date time. We're going to be passing in the full URL to that source, and we're going to tell it this time it's a CSV. So this is basically telling KQL to split on the comma, and we're going to say ignore first record equals true. And what that's going to do, and this is important when you're using external data. So this is obviously not a date time. If I was to try and pass this through without saying skip the first row, we would essentially try to parse this at a date time and fail. So since we have headers here, I'm essentially replacing with those headers with these columns and telling it what type. I'm saying ignore the first record. So when we run this query, we'll bring this directly into your query results, which once again, you could be used for filtering and joining and such. Let's look at another example here, and let's see if we can do something that has some real world has a real world example. So let's look at identifying Azure subnets. So let's say you wanted to look at a remote IP address from one of your endpoints and determine whether or not that particular IP address is in Azure. Now this is a little bit more advanced. I'll show you a couple tricks here. So this is essentially an XML file that we publish that has all the different IP address ranges associated with different Azure subnets. In this case, though, parsing it directly as text, it's a little bit easier, to be honest, to just go row by row and just pull out the subnet where it's present. So what I did is I wrote a little query that goes out and it pulls it in as a text file instead of XML. And then I create a new column called subnet. And that subnet is essentially, we parse the current row, XML, this is this column here, parse the current row, looking for the IP range, and then the subnet field. So essentially, if you take a look, we're looking for IP range objects and this subnet field inside of here. As a result, this is going to give us a nice list of subnets. We're going to go ahead and get rid of empty entries for subnet because there's going to be some of these that are not going to be populated because the IP range may not be present or whatnot. And then we're going to use a summarize make set. So if you were on our JSON episode, make set is going to essentially give you a deduplicated JSON list of subnets in this case. So you can see we have here set subnet. And it's going to have all the different subnets that we have. Now, there's another operator here you may not be familiar with, which is toScaler. And what toScaler is going to do is toScaler is going to take a tabular input. So right now, technically, this is a table. Even though it's a single cell with a single row, this is in tabular format. Since I know this is going to come back as scalar because I'm not summarizing by anything, I'm just saying summarize all these subnets into a single cell, I can specify it to be toScaler. Now, this is what makes it a little bit different. So now if I was to do Azure subnets, this is going to fail because Azure subnets is not a tabular value. So because it's scalar, we'd use print. And this is effectively the same thing that we just did a moment ago when I broke out the query. And you can see we have all these subnets. Now, why make it a scalar? Because we want to be able to do some joins and pivots on this in a kind of a fancy fashion. So I made a little function here, which functions we'll cover in a future episode. But essentially, this function is called IsItAzure. And I'm saying we're going to pass in the remote IP address from the source data I pass in. So I named this source data, and source data has to have remote IP, and remote IP must be of type string for this to work. So source data, we're going to go ahead and add in the Azure subnets from before, MV expand, which is going to multiply those out, and I'm going to use this really cool operator that's out there called IPv4 is in range, and it's going to compare the remote IP address that we have on the current row from the data we passed in to the current Azure subnet. And since we MV expanded it, we're comparing it to all of the Azure subnets that we have out there. The last thing we have in this little function is a summarize. We're going to look for the max IsItAzure by remote IP. Since we're comparing the individual IP to a large number of subnets, and this is going to be a Boolean result, where false is going to be 0, true is going to be 1. Max of IsItAzure is going to let me know if it was in any of the Azure subnets that we compared it to, essentially telling us, did it come from Azure? Now, to call this function, we're going to use a term here called Invoke, which is you may know from your file profile functions and such. Essentially, Invoke is going to pass the results of whatever query comes before it into whatever function you specify after Invoke. And source data is going to be the default parameter here. And you'll see in here that we've got a bunch of, actually, let me go ahead and get rid of my filter here. Right now I have a filter showing where IsItAzure is true, but you can see that we've got true and false along here, essentially showing that there's Azure and non-Azure IP addresses that are in the mix. Kind of a handy example of how you could use this. Now, probably another great real-world example here is you can use this if you have let's say a CSV formatted list of subnets for your organization. You can store that out in blob storage somewhere and provide the URL with the SAS token and then import it at runtime into your query results using Invoke. So feel free to copy this and reuse it. Again, this query is available in the webcast folder. It's also, I believe, under the general folder in our advanced hunting GitHub. And as a note, so it is important to note that when you use external data, the URL you pass it must not require additional authentication. In other words, there's no way for it to prompt you saying log on or approve or whatnot this query, this access to this data source. So blob storage with a SAS token essentially provides you with the URL that has the query embedded in the URI stem, which enables you to get around that. Let's take another look here. So let's take a look at the Malware Bazaar. So in this case, we're gonna take what's essentially a little more difficult output. So Bazaar abuse CH, CSV is recent. So these are basically the latest threats that abuse.ch is reporting in CSV format. In this case, we're gonna deal with. So if you looked at the raw data, in fact, let's go ahead and take a quick look here at this one. You'll notice there's a bit of a challenge here. Go ahead and take 100 rows. So one of the things that's really can be a challenge with using external data is the formatting has to be done just right. Now, it becomes a challenge, like in this case with this particular CSV, because there's some header rows in it that have hashtags before them. So if you were to feed this in directly as a CSV, it's probably going to fail in your query. Seems to be taking just a moment here. Apologize, this is not playing with me today. There it goes. The demo gods are not being kind to me today. I apologize for this brief interruption here. If not, we'll just go ahead and move forward. I'll give us another couple of seconds. But essentially, the raw data in this CSV has a header that has a number of rows that have a hashtag before it, and the rows do not match the hashtag. So one of the tricks I was able to do is I imported it as a text file instead of a CSV. Once we have that in, I can filter out where the report row doesn't start with a hashtag. So essentially stripping out those header rows and then calling parse CSV, which is going to parse the row as a CSV. From there, we can we're basically manually performing the CSV parsing at this point. We're going to go ahead and parse it CSV, and then we're going to add in string or date time values that match up to the individual columns that are inside of that report. So kind of working around, so one of the tricks to working around kind of difficult formatting is to just import it as text and implement your own formatting. From there, what we've got is I'm focusing specifically on the SHA-256 column. I'm unioning together the abuse feed, looking for process creations, file creations, or image load events where the SHA-256 match, in this case, within the last 7 days. So kind of an interesting example of how you can get around some challenging file formatting. The second topic for today is a fairly advanced one that larger customers are going to experience more often than smaller customers in many cases, which is data partitioning or query partitioning. So in the advanced hunting pane, you can have up to 10,000 results. Via API, you can get up to 100,000 results in a single call. But what if your query returns more than 100,000 results? So for example, let's say you wrote yourself a custom report of all of your endpoints, and you've got 200,000 endpoints inside your organization with 1 row per endpoint. Or maybe you've got just a general query that happens to bring back over 100,000 rows. We need to have a way to split the results up over multiple calls. To do that, we're going to use data partitioning. And so the easiest way to perform query partitioning is using a function called hash. Now, hash is not exactly a cryptographic hash in the sense of SHA-1 MD5 or SHA-256. What this is a very, very fast in-memory hash called, currently is using XX hash. It takes the value you have in there and comes up with a relatively random hash value. And you can optionally pass a second parameter, which is like a mod operator, essentially like a modulo. So you can split it up into n numbers of groups. But once again, hash is not a cryptographic hash. So if you're trying to identify uniqueness of a file, I would not recommend using this for comparisons. Let's go ahead and take a look here. So we're going to make a table. It's just going to have one column called input with our foobar baz string, and then we're going to extend, if I can spell it today, hash value. We're going to extend out hash value is equal to hash of the input. So when we run this, you're going to get a little, it's closer to like a CRC, if you will, of each of these individual strings. You can see that there's some interesting trailing zeros we have in here, but it's hashing this input and providing a deterministic pseudo-random value as a result. Now, the second parameter is where it becomes really handy for query partitioning. So let's say we wanted to break our query up into 3 different groups. If you put (3), this is going to take the output of the hash and it's going to do a mod to it. So you're going to get back 0, 1, and 2, and it's going to slice the query up. Now you'll notice that there are a few more rows in 1 than 0 and 2, and we're going to dig into some analysis around that in a second. It becomes really important as you start to deal with large amounts of data that get split into potentially not even chunks. Now, when you're performing partitioning, you want to make sure that the partition key is reasonably distributed in the data set. Let's go ahead and take a look at device process events. We're going to go ahead and do a partition here where the hash of device ID, we're going to break it down into 4 different partitions and then count the number of results, how many distinct device IDs are in each individual partition, and then by the partition number itself. What you're going to see is we've got, so the count is representing how many rows were in that particular result. So 93,000 here, 55,000 here, but 11 distinct device IDs and 13 distinct device IDs here. And so there's a bit of a disparity because remember, we're essentially grouping these together based on a set of the device IDs. There's no guarantee that every device ID is going to produce the same number of rows in your query unless it's one-to-one. So it's important to note how these are distributed so that you don't accidentally overfill one or maybe cut your output in half. Let's take a look at something a little more distributed yet. If we use timestamp, for example, as our partition key, you'll see that now timestamp is 100 nanosecond resolution measurement of when a given event happened on a device. You'll see that we've got exactly 52 apiece here, and they're pretty evenly distributed. So this is a well-distributed key. It may work out for you depending on the kind of query you're looking at. It may not. For example, these queries can be running at different times. So it's possible that a couple of the later events in your query results may be after, or may not be included in the second, third, and fourth partition if you use something like timestamp. Now, when you're performing this partitioning, so essentially we're trying to get around the 100,000 row cap we've got on the API most of the time. What I normally recommend is using variables. You'll see we've got partition number is 3 and partition count is 5. So in this case here, we're going to have probably, let's say theoretically we had around 400,000 results. We're going to break it up into 5 partitions to make sure they all fit. And in this case, we're looking for the third partition number. So this enables you to reuse the same query and just change this from 0 to 4. Remember that since this is a mod, 0 is a result, 1, 2, and 3, and 4, but 5 will not be there. So it's important that when you're doing your partitioning, that 5 is going to be how many groups, but it starts at 0 with your partition numbers that come out. Now, if you're performing a join or a summarization, you want to make sure the partition key that you choose aligns with the join or summarization. In this case, we're taking device process events, and we're going to go ahead and partition based on SHA-256. But afterwards, we're going to summarize the count of rows by file name and process command line. Just a contrived example here. The challenge here, though, is that a SHA-256 can have the same SHA-256 can have multiple file names and there's not a one-to-one correlation there. So it's possible that you may have to add these results together at the end of the day because the SHA-2 may be represented in multiple different data sets here as a result. So something to keep in mind, you want to keep, if you're going to be counting something by like file name here, you'd probably be better off using file name as your partition key in this case. That way these are aligned. The second thing is that I mentioned I have an example here for you in this. So partitioning is not usually perfectly distributed. So we broke this up into 20 different partitions. And if you look at the results, there's a wildly different number here. You have 439,000 here, and we've got 866 here. So depending on what you're partitioning on, it may not be evenly distributed. This is really important, again, because if you go over that 100,000 cap in one of your partitions, you're just going to see 100,000 rows. So we need to have a way to determine what the proper partition size is going to be to make sure all of the individual results fit within whatever cap you specify. So I'd like to introduce a handy query that I put together that'll help you figure out the minimum workable partition size for any query. And we're going to break this one down. So the first thing is, this is going to be the query that you want to run. I'm just going to go ahead and say device process events, give me 100,000 of them just for an example of what the query would look like. The key column here, which is essentially the one that we're going to do a partition on, is going to be device ID. So we're going to try and group these into different partitions using the device ID. And we're going to specify the maximum number of rows that can be in any one partition as 200,000. This is going to be our API. You would probably set this for 100,000. You may have other reasons to reduce down the data set to 20,000 more or less, whatever it might be. We're going to say we're going to try 10 different partition sizes to see if it fits, and we're going to step them at 1. So essentially, this is going to be like a for each loop, if you will, a for loop, pardon me, if you will. That'll take a number and keep adding up to 10 more to it to try and figure out a size that works. So On line 161 here, we're going to clean the query up. We need to standardize this in order to process this query. So I'm going to take the query that's specified up here, and we're going to determine if the column name that was specified exists. If not, it becomes column does not exist, and essentially it filters out. If the column does not exist, then we don't go any further, because this is not it just is not going to work. We don't have a query a column to partition on. So if it does exist, we're going to go ahead and set that to key. The next thing we're going to do is we're going to figure out how many rows are in each individual key value. So if we take our clean query, summarize how many rows we have as a count by key, and then we're going to figure out what the largest one is. Why? Because the largest number of rows in any individual key is going to help us determine the minimum partition size that we could start with. Because if you've got 50,000 rows in a single partition, we can never meet a 20,000 row partition size. It's just not possible. But this gives us a starting point so that later on we can figure out how many partitions we're going to need to try. Because again, even though this is the largest one, it doesn't necessarily mean the partition schema is going to work. So the next thing we do is we once again are using our toScaler to turn this to a scalar value. We're going to figure out the minimum possible number of partitions we can use in any case to group this together as specified above. So we're going to take the clean query, figure out the number of rows that we got here, and the distinct keys, which is equal to the distinct number of keys, and then comma 4. This is just because of the higher accuracy. And then we're going to figure out the max rows divided by the max rows per key, and then multiply that by the number of distinct keys we have in there. Essentially, we're trying to figure out how many rows will they fit and how many distinct keys are going to be inside that group. And last down here, we're going to put it all together. Go ahead and run this now. It takes just a second to run. We're going to figure out how many partitions. We're going to try 10 different partitions in this case. We're going to start with min partitions. So min partitions is going to be the minimum numbers that could possibly work in this data set. And then we're going to go ahead and do that, range it from that number to the min partitions, plus the partition size to try it, time the step size. So essentially, we're going to take this 10 different partition sizes, and we're going to multiply that together, and then step it whatever our step size is. So in our case, this is going to be the minimum number of partitions, and then 10 plus that, step one at a time. And then we're going to go ahead and hash that key. So as I mentioned before, hashing is essentially a mod operator. So for efficiency purposes, we're just going to go ahead and hash it once and use a bunch of modulo operators to calculate it. We then expand it out as an integer, extend the partition number as the hash modulo the partition counts. This is going to tell us which partition would fall in. Then we're going to summarize the total count by the partition count partition number and determine whether this is going to work. So if the row count in that particular partition is going to be less than the maximum number of rows, then it's going to work. Ultimately, we're going to do our same trick we did before with the Azure subnets. We're going to look for, we want to make sure everything is will it work set to true. So we're going to do the minimum of will partition size work by partition count to make sure there are no falses if we were to use that particular partition size. Filter out anyone where it didn't work, and then ultimately figure out what the minimum partition size it is that would work in this data set. Now you'll notice I got a blank back here as a result. This is because in this particular set here, there's no way we can get a 20,000 use a 20,000 row partition because there's more than 20,000 rows in a single partition. If we were to bring this up to, let's say, 50,000 though, and run the same query again, it's going to tell me that with a partition size of 50,000, the minimum partition size I can use with this query is going to be 54 if I group it together by the device ID. So I know a lot of really advanced stuff here, but this is how you can get a larger than 100,000 row query through the advanced hunting API if need be. Really handy for especially larger enterprises. Good to go. And then, Heike, do you have any the follow-on slide?
I do. It's my turn.
All right.
Okay, so thank you so much, Michael and Tali. Some reminders before we are ending the call. The recording will be made available at aka.ms/security webinars. And for registration and details for future webinars, go to aka.ms/security webinars. If we have missed to answer your question, or if you have additional questions, you can visit the Microsoft 365 Defender forum at aka.ms/m365dtc. Again, thank you so much, Michael and Tali, for this l33tSpeak episode. Thank you to the rest of the team who helped answering questions. And most of all, thank you all for being part of our community and for joining us on those webinars. We hope to see you next time, and goodbye.